Hello, this is Max. We're working on Fall 2013, Midterm 2, Question 3, Problems Mutants. Given two R-list arguments, A and B, the function merge A changes A so that it also includes all elements of B at the end, but does not change B. Okay, what's an R-list? The R-list class is defined in your study guide. I've brought up the R-list class right here. Here's some things to think about. We've got an empty list. So we have a class empty list, and we're setting rlist.empty equal to that empty list. Other than that, we've got a first and a rest. This is beginning to look a lot like link, if you're watching this in spring 2015. A get item, a length, and a repr. Extend rlist is sort of an example of a method that takes two rlists. So maybe we can use this as inspiration for our merge. And then let's finish, well first maybe let's finish reading what it is asking us to do. So it's asking us to change A so that it also includes all elements of B at the end, but does not change B. So it's sort of asking us to tack on B, but make it so that it's not actually referencing B, so that any change we make to B should not affect A. And our first is first, type rest. So we have no restrictions on what first could be, but it looks like for this problem we could pretty much assume that first is just going to be an integer. But anyway, yeah, so you don't always want to make that assumption, but let's see what we can do with just this. So add the elements of B to the end of A, mutating A but not B. So we've got A is the R list 1, 2, 3, which is going to look like 1, right, points to 2, points to 3. And B is the R list 4, 5, 6. And each of these point to each other, okay. And then when we merge A and B, what we want to do is we want to tack these values on, but leave B pointing to itself. So we don't want anything to point to actually the B object here. So A should be modified, looks like it is. B should not be modified, isn't, great. B dot first is 7, so we change B to be 7. This should still point to something that starts with 4, right? Okay, great. So we're going to actually need to extend this. There's a hint here that we're going to actually need to construct new R lists, it looks like. That's fine. Okay. Here we go, hint. There's a base case. If B is R list.empty, then we just want to return. So if we're just given an R list and we get 1, 2, 3, and we're passed an empty R list, then we're done, right? We can just return straight out of this. So this is a great big hint. You see a base case, you should think, so I want to do this recursively. And also we're not giving you anything to do iteration on. This looks like a pretty straightforward recursive candidate. Okay, so we're past A. A is really just this thing, right? This is what A initially looks like. So if B is not an empty R list, so B actually has some substance to it, what do we want to do? So maybe we can treat this case as the case where B actually has something in it. And let's also think about sort of the easiest thing that we could be passed in as A. So A, we could be passed in something that has a single value, and this points to list none. So we'll sort of think about this as, this is hard. This is list none. Okay, so else if, let's say a.rest is rlist.empty. So B must not be empty, right? So it would have passed this test. It would have gotten into here and returned. So we'll see a.rest is rlist.empty. So we're adding something to the end of some list. That's sort of the first case we want to think about. So our simplest A is this. If a.rest is rlist.empty, then what do we want to do? We want to set a.rest to something new. A.rest should then be equal to, so now we're adding stuff onto it. So say we're given something like 1, 2, 3. So our A is this, our B is this. We want to extend A so that it looks like 1, 2, 3. But doesn't actually point to this, right? So we need to make a new R list. R list, and our constructor is, we get rid of first, and then if we don't give it anything else, you can see here rest equals empty. It's going to default to just being an empty list. So if we were constructing this from here, the first thing we're going to think about is just adding on, we'll first just deal with adding on this list right here, right? And we'll sort of think about adding on this first element of B. So R list, we want to make a new R list. We're setting a.rest equal to this new R list that's going to have b.first as its starting value. And we're going to end this call right here. So we're going to say that by default this is going to have an empty list. And then when we want to add something to this list, what we're going to do is just use this merge function that we're writing. And we want to merge a.rest with b.rest. Okay, so why is that? So a.rest is now equal to this. So now we want to merge this, which is going to be the end of this new list that we're making, with, we don't want to duplicate this 1, we want to merge it with this, right? So now we want to add on 2 with an empty list at the end. And now we'll move this on. So now our a.rest is going to be this, until finally we've added all of the elements of B on. Sorry about this. B on, right? And now b.rest is going to be empty. And so now we're going to terminate our condition. And we will have changed, we'll have made a whole bunch of new R lists that add on to A. Okay. Also, note that we satisfy this condition right here so that we're not actually going to send something that points to B. Anytime you see something that you say you want to essentially copy over a list, you want to make sure you're making new R lists or new links or whatever. So, okay, great. So this looks like we've done a good job here. And now else, so now we can think about, well, what's the other case that we could have? So we sort of dealt with our simplest version of A, but what if we had been passed something like this? Well, we eventually want to get to the end of A, right? So that we can start adding things onto the tail end. Because we can't do anything with just A starting at the beginning. So we're going to try and get here. If we start here, what do? We just need to merge a.rest with all of B, right? Because we haven't started actually adding elements yet. Okay, great. So this is problem 2a. So now there's sort of a follow-up to that. Define a mathematical function f(m)n such that evaluating a correct and efficient implementation of merge A on R list A of length m and R list B of length n requires theta f(m)n function calls. Whew. Okay, well, let's assume that we didn't. Well, we can use our implementation here, and we'll think about what we had to do here. So here, how many list elements are we ever going to inspect? So if we get passed in a list of, an A list of length m, which is what we're getting, right? We need to go through m minus 1 calls to merge until we're at a point where we can actually start adding stuff, right? So we're going to do m minus 1 calls until we're at the end of the list. And then what do we have to add additionally? We have to do plus. Once we're at the end of the list, we need to add on all of our B terms, which is going to be n. Okay. And so it depends on whether or not you consider R list function calls. But so for the purposes of this, since it's also in theta time, we're only going to think about whether or not this is constant or a linear growth sort of thing, or whether or not it's quadratic. It looks like this is going to be constant for both of our quantities m and n. So what I would write here is m plus n. Okay. So we can see that as our length of A grows, so as our length of A grows to be huge, this huge number, we're going to have to go through each of those items, but we're only going to have to go through each of the A items once until we're at the end of the list. And then for n, all we need to do is add each of our items in B to the end of our A list, right? So we're only going to look at this n times as well. So m plus n seems reasonable. Please follow up if you have any questions about this in Piazza or on YouTube. Okay, thanks for watching.